Thank you for being here. To be honest, I had some confusion in the meeting room, but it's good to be here and it's good to finally see all of you. Today, I've only got 19 minutes left, but today I'm going to share with you in a very historic city what the future of architecture could be. All right, so from where we are practicing in Singapore, it's a very small place, it's a very small country compared to India, compared to many of the countries you're from. It is also fairly rapid in terms of development, so all the time we've got to think about how we can develop fresh, we can develop new. Before that, who was in the JAIPUR Architecture Festival about 2 months ago? All right, probably about 20%, right? Some of you guys. The content, or rather the structure of the content will be fairly similar, but I've updated it with some new projects, all right? So you don't have to worry about falling asleep in the next 20 minutes, all right? So who's from India? Okay, good. I'm talking to the right audience in the right place then. All right. So I'm going to start off with asking once again, how's the weather today? It's hot, right? It's fine inside here, but it's 41, 42 maybe outside. It's extremely hot, right? And this used to be a conversation starter. Now the question has become a lot more loaded, right? And that is because by the end of this century, right, there will be places in the world that are no longer inhabitable. Right, and we certainly hope Jaipur won't be one of them, or we'll be stuck in air-conditioned rooms 24/7. I'm just going to show you very quickly the work I've done as an architect, as a practicing architect. Of course, not my work alone, but the work I've done with various firms who've had the courage to push for something new. Right, and who've also had the mercy of actually employing me as a fresh graduate back then. So as a fresh graduate, I was working on this project. It's a project by Woha Architects, and basically, it tried to actually bring the ground level, sorry, the pointer doesn't work on the LED, but what it tries to do, it tries to bring the garden on the ground up to the sky, right? And that's one of the first examples, at least in Singapore, of projects where you can access green visually on a skyrise sort of level. And do you think that's sustainable? Maybe, maybe not, but what it does give, it gives a certain imagery to what green architecture can actually be. And a bit more on that, basically it takes the whole ground level up, it raises the whole building, so the podium becomes a bit hollow, it becomes a bit more porous, and as you go up, basically on the pool deck, you can basically see the sky gardens and so on that's coming down as well. And that extends to the interiors where you have visual access to green all the time, and that was before everyone got a bit crazy about this concept called biophilia, where visual access to green means you become healed, you become more well, so to speak. Right, a couple of other projects. These were actually two existing buildings. The buildings in white, they are conservation heritage buildings in Singapore. So we've come in and added a sort of a slightly invisible or a camouflaging glass block in between. Europe is amazing in these kinds of projects, old and new, right? India also, for some of the new projects that have come in. And what we've actually done is to conserve the existing and insert a new use with higher density and a new purpose as well. In this case, it's become a furniture showroom, and that's what it looks like on the interior, and it's also an elegant treatment. So, in a way, sustaining through conserving the existing. Because in Singapore, from the 1960s, which is when we got independence, till now, a lot of the old towns were actually raised for new developments, and it's only in the last 10 to 20 years that they've decided, hey, we got to start conserving. This is part of us, this is part of our culture. Other projects along the way, basically this is an industrial building, an office building. We've, instead of recommending to demolish the whole building, we've actually taken this and conserved the existing structure and given it a whole new face and added layers on top. So conservation through structural sort of preservation as well, because buildings in the past were quite robust, right? So basically saving the client about 30% of the cost in constructing the building otherwise. A couple of newer work that's currently being done. Of course, for some of the projects, we start looking at business parks and townships, in this case in Trivandrum in India, an IT park, and similar concepts of the landscaping integrating with the gardens, integrating with the interior spaces as well would come in. And this is part of the clubhouse, right? So even though it's a fairly sort of hard-edged type of development, an IT park, we've decided to make it as soft as possible and as tropical as possible, seeing that this is in Kerala. Another project in Thornacle this time, also in close to Trivandrum, Basically, this is a hospital for the Kerala Institute of Medical Sciences as a concept proposal, right? The project still going through some negotiations, but basically it's an idea. What happens is you have one wing that's for the immediate care sort of patients, and one wing that's for psychiatric care for the patients as well. So sustaining and conserving not just the environment, but preserving life for as long as possible, even though you know that, hey, you know, these patients will probably not recover, right? Or it's going to be tough for them to recover, and also, especially patients towards the end of their lives. So how then do we create environments that are most comfortable and most dignified for the patients as well? And ultimately, I think from a more technical point of view, using the existing climate of Bangalore, right, the existing cooler climate to cool the data centers, this being a data center and an office project. So instead of pumping in energy to cool the data centers, we naturally ventilate the data centers such that they can be cooled by natural air. And of course, when you need, augment that cooling process, seeing that data centers or the servers are extremely heat generating. So this is Singapore. Where is the discussion now? If you do live in Singapore, there's barely an inch of real estate area that's not been used up, right? They've planned it in such a way that it does not feel as dense as cities like Hong Kong and so on maybe, but it is fairly dense as well. So what is the next stage for architecture? Instead of talking about just stylistics, instead of talking about, oh, who the next big thing is, right? What is the general feel? And I'll give you a little bit of insight into that. So today, basically, we talked about climate change. We talked about, having sufficient good air quality as well, right? That's not happening in the urban environments. We've got this guy who's proposing for, you guys recognize him? What, the one that's facing us or the one whose back is facing us? Both, right. So you've got these guys pushing for climate change and so on, right? And of course, he died in the polar ice caps about 20 years ago. And then you have this guy, right? Basically goes, climate change does not exist, it's a myth, right? So how do we as architects operate within such a global climate, right? Europe is pushing, of course, any discussion on climate change. Europe is pushing for basically reduction of carbon emissions, right? Reduction of fossil fuels. Diesel cars will be outlawed in some countries in Europe, right? So as a mode of practice, as a mode of understanding the environment in which we work in, how then can buildings become more green? And that is basically my whole thesis for today. I know I've got 10 minutes left. So cities are also becoming denser, right? Everyone's moving from the villages into the cities. But can worldwide infrastructure cope if we don't plan smartly? This could be what will happen. So in Singapore, we try a few things. We legislate sustainability. Buildings have to be of a certain green mark rating, which is a rating system. But more than that, sustainability is supporting the existing ecosystem and perpetuating our way of life, our way of living, our way of livelihoods, and also perpetuating the nature that comes with it. Therefore, it is about longevity. And in Singapore, how do we preserve that longevity? It's a tiny island. I'm not sure if you've been there. Anyone? I know some of us operate from Singapore. It's a tiny island. So what they've always tried to do is to expand the physical limits of the island, right? Because the theory is, of course, the more land, the more space you have. It doesn't have to be on-ground land. The more space you have, the more real estate you can sell, the more the economy grows, and so on and so forth. But again, there is a limit. So land in the sea, land below, space below the land, and land in the sky. And basically, this is how the country, the original one is a lighter bit of pink, and the darker pink is really how much a country would have expanded by then. And that is originally 570 square kilometers, is going to expand to about 740 square kilometers, which is about 40% increase. And that is quite massive in terms of percentage, right? So that's expansion into the sea, basically pushing out some of the industrial requirements, industrial estates and so on, towards the far sides of the island, pushing out the port facilities towards the southwest and so on. But ultimately, there are limits before our friendly neighbors start going, hey, guys, you know, that's a bit too much. You're coming into my waters. And if there's one thing you should know, right, Southeast Asian waters are probably one of the most heavily contested in the world. Down from the time of the pirates till now. So what we've also done in Singapore is actually to dig below the land. So this is basically a cavern that's about 150 meters below the land, and also concepts of an underground science city where if your work is in research, if your work is in laboratory work, you don't actually have to have access to daylight all the time, right? So from time to time you can come down somewhere and then there's a light shaft and then you can bask in the light and then go back to your lab subport. But what that does is it expands upon the ground real estate that we have. And a couple of projects we're working on is also determining what is a new urban infrastructure and typology that can exist above port structures. So in this case, creating a new urban typology that hovers literally like a machine, or hovers like a new sort of a table or a new plane, tableau that's above the existing port structures. And in doing so, it's quite interesting because no longer are you looking at the ground plane as the ground plane. You're looking at something that's high up in the sky, and you're therefore looking at, well, not that high, maybe 40 meters in the sky, and you're looking at new modes of creating urban guidelines that come together with it. What sort of new landscaping could come along, but still allow for the port function to function below. And what it also does, it reduces the carbon footprint by quite a bit, because instead of transporting container material from the ports into the storage areas and back, what you can then do is basically distribute them within these sort of areas that are above, within these areas, right? Above the container ports. So there's a lot of transport that's being saved as well. And ultimately, there are physical limits. So what we try to do is basically to expand upon the use of a building. And one of the concepts really is that, hey, look, this room is being used maybe till the afternoon when the conference is over, but by night, nobody uses this room, right? So we're building probably about 80% more than we should, because if you go to school, if you go to office and so on, by the time 6, 7 o'clock comes in the evening, the building's unused. So for half its lifetime, the building is pretty much useless, right? So how do we enable buildings to be used 24/7? And how can their functions be also used or changed over time? So here's a project that's quite interesting. It's a very small project, probably the smallest one that you might have worked on. It's probably about a quarter or maybe about half the size of this room, right? It's a box that actually rotates on top of a roof of another building, and it's a plug-and-play building where you can change the facade, the lighting, the air conditioning, and so on to test new building systems. So there it goes. I can't play video here, unfortunately, but basically what it does is it rotates, and it tries to simulate the building angles relative to the orientation of the sun. So what happens is, if you're a developer, you're an architect, you want to try how your building is performing based on the orientation of your site, you could actually simulate and mock up all the materials within this particular environment. And internally, the building has more than 150 sensors. So what it does is it tracks everything from your thermal output, right, to your glare, to all these sort of things that can enable the building to record and dictate what is then best, right, as an internal environment for both visual and thermal comfort. And here's a lounge that was also created, and this is one of the first buildings in Singapore, new buildings actually, that uses timber. It was outlawed because of its fire risk. Some photos. And I guess it's a simple building, but what it really does, it creates value and it adds data to the building, in that the sensor data actually comes into here. Right? The resolution is not sharp enough, but basically this tells you the temperature at all the different points. So of course, when you have occupants, this data changes and so on. And what it then does, you can calibrate the cooling within the building, you can calibrate the lighting levels and so on within the building as well. And you can visualize such that basically, in this case, air conditioning, what is the water temperature that goes in, that comes out and so on. You can therefore calibrate, and through, over time, pattern recognition and data trending, you can basically enable your buildings to sort of respond to the number of occupants and the nature of the activity within the building itself. So a lot of the tools that we therefore use would enable the building to become a bit smarter in that sense, from the design point of view all the way down to construction. So basically, these are simulation tools that determine how much wind is flowing through the building in this case. And it allows us to create buildings such as this. This is the new architecture building for the National University of Singapore, the university I graduated from. We didn't have this building then, but effectively it is the new net zero energy building in Singapore. So what it does is it basically harvests as much energy as it requires, nothing more and nothing less, in theory, right? That means the whole roof is lined with solar cells, right? The usage of the building, if you think architectural studio, you think an air-conditioned space and so on, right? We use actually a different system where big fans would actually kick in when it's cool enough, just get the air going and so on. When it gets warmer, if our temperatures ever hit JAIPUR temperatures, when it gets warmer, the air conditioning kicks back in. And we found that it saves a lot of energy, meaning to say on a day-to-day basis, we're using too much air conditioning, right? Now, I'm not about to recommend you turn off your air conditioning now, not in this month, not in Jaipur anyway, but still. And then we move the discussions out and expand them into what a smart city actually is. And if you look at this, this is a typical Google image search for a smart city. What you then get is information management, administration services, and so on, everything that's connected, right? But there's always very little talk about culture and its response to people and its response to the environment. So likewise in Singapore, we've got all these facilities and all these solutions that could actually qualify as a smart city. But worldwide, there are always times when infrastructure does not meet demand. In this case, this is in Los Angeles. In this case, photos of a traffic jam in China that took about 11 days to clear up. And people actually die in these things. No joke, right? So how, as architects and planners, can we then plan for the future, not just in terms of building, but also in terms of infrastructure? And in this case, in my experience with students of architecture in the universities in Singapore, the discussions always are centered around density, 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 hyperdensity. Right? Occasionally, again, this is a study by Woha. You've got a lot of greens. It's out there, vertical farming, urban farming, and all these sort of concepts. Right? But again, anything that is finite, anything that's physical has a certain limit. Again, if we push density too far, these are case studies in the world that have not survived that test. So we start looking at master plans not in terms of a fixed master plan, but something that could actually change over time. Right? And I don't have time to play the video necessarily, but what we've actually done is to actually program a set of simple parameters for a new urban plan, such that the city could take on different forms depending on A, the need for density, depending on how the economy of the city is doing, then maybe you build less, and depending on C, what the new governances or the new governance models could actually be. So we could put in all these variables, the city could grow and evolve along the way, and I think that could be the future of urban planning. So one quick example to close off basically is a proposal that we've done in Pattaya in Thailand. Right? Pattaya is a fairly well-known city for its various nightlife activities, but basically they're trying to change that impression of the city to become more energy efficient and to become also the hub for new startup technologies. So a few proposals, basically zoning it such that there's sufficient green. I think there's always base case plans for a city to determine how much green cover there will be, right? How much of it actually will be renewable as well. So we have a clean energy farm taking up 13% of the real estate, for example. Smart governance, what is the mode of controlling all these different estates, whether it's government invested or whether it's private models of investment and so on, and determining in the economy how the whole city will be sustained across 5, 10, 15, 50 years. Right? Very often architects do not get into that discussion and they realize at the end of 10 years, the master plan fails. Smart mobility, having a sort of a spine of automated vehicles, of autonomous vehicles, and also of cyclable estates. And the idea of community and happiness, where everyone gets engaged both in terms of software as well as the actual hardware and the architecture. And the smart environment, smart building, we've talked about that a little bit. Smart energy in terms of renewables and how it detects emissions and so on. But ultimately, in a lot of the countries and communities that we work in, how do we transcend the language barrier, right? And one way of doing that is actually to create these very simple diagrams wherein on the planning sort of stage, as you're master planning the whole place, you determine, okay, to maximize porosity, you determine the maximization of green cover and the space between buildings and emissions detections. You minimize the reflective spaces, you create barriers between roads, parks, and, between roads and parks and residences as well, such that noise is always controlled. The use of electric vehicles, the monitoring of carbon emissions, and ultimately the use of smart grids, wherein the consumption patterns can be more refined, can be more defined, and therefore you would save quite a bit of energy in that sense, ultimately leading to a sharing of saved energy as well. So the magic really is between planning and implementation in the kind of work that we do. And in closing, just a few quick examples of smartness in architecture. We're designing facades with glass, basically glass that becomes more opaque as it gets hotter and it gets brighter out there automatically. Basically allowing for people to basically come in and determine, hey, this is how much we're consuming today, this is the temperatures, and so on. So it gives you an idea of how much energy that you, as a user of the building, are actually using, and that could become an app as well on your iPad. And basically, from a facilities management point of view, right, you would come in. If the temperature drops, what usually happens is you get a bit cold, you call someone in, and the person comes in and sets the air conditioning. And in a smart building sort of environment, got it? In a smart building environment, basically you come in, the system sort of tracks and does that for you, and ultimately you get a bunch of happy occupants. And the building can also detect who you are, which could be a bit scary, but effectively it leads you to where you need to be, right? For example, if you booked a meeting room, and again, if you're a regular employee within a building, let's say, what can then come in is basically your assigned hot desks and workstations, right? We've also found through studies that at any point in time, usually there's a 15 to 20% absentee rate, right? So we're, again, over-providing for desks at any point in time. So in this case, you can use a hot desk, and that'll be programmed into your circadian rhythm, such that by the evening it gets dimmer and the lighting gets controlled, and you feel the urge to therefore go home. Or not. Therefore, innovation and magic again lies between the crossroads of architecture and engineering. And now that we're in Jaipur, here are a few lessons that we've learned along the way, and basically looking to the past, right, to determine what we can do for the future. So this is at Fort Amber. Basically, the windows are smart in a way that if you look up, or rather if you look down from where the fort is, right, they're angled in such a way that you can see what's coming, but of course, from below you don't get that visual connection as well. This one, of course, this is a smart facade because it is almost fully naturally ventilated when it's fully open, right? And tradition and the vernacular has taught us quite a bit about how to respond to the environment. Somewhere along the line, we've lost that, right? Through glass, through steel. And ultimately, a smart building that tells you the time. So the future of cities will be high density. That's a consequence of population, will be diverse, will be exciting, be smart, and hopefully will be sustainable as well. And it could be so much more. So with that, thank you very much.
Thank you, Tan, for that wonderful presentation. I now call upon and first introduce Mr. Dharmali Kusmadi. He is the Managing Director of Architrave, a leading international design firm, and the architectural design arm of Banyan Tree Group that specializes in architectural design, interior design, landscape design, and master planning services for the hospitality and residence projects owned and managed by the group. In more than 2 decades, the group, Mr. Kusmadi, has helped to create the iconic award-winning architectural interior designs, which are the hallmark of Banyan Tree and Agsena hotels and resorts. He has personally involved in projects in Maldives, Thailand, Philippines, Indonesia, China, Mexico, Morocco, Seychelles, and many other upcoming destinations. He was also involved in Asia's first integrated resort project, Laguna Phuket in Thailand. The recent open Laguna Lang Co in central Vietnam, and more integrated resorts in years to come. Please, sir, I will invite you on the stage now.
Good afternoon. Thank you very much for the opportunity given to us. Before I starting my presentation, our approach here is not only from a design company, but it's also from a commercial company, because our owner is the holding company is a public listed company who doing hospitality. So we have a responsibility not only providing a good design, but also design which meet the bottom line. We are operating in 30 over countries, more than 40 resorts, and all started in this site. In '83, our founder bought a site in Phuket where it's cheap because it's moonscape. It's beyond repair. This is in 1983 in Bang Tao Bay in Phuket. It's an extinct mining. It's heavily polluted, but have a beautiful white sandy beach. And in 1977, UNDP already overruled this site that beyond repair is too environmentally damaged to have any development potential. So they rule it out. That's why we bought this one, because it's cheap. And after about 10 to 12 years, we turned into the first integrated resort in Asia. We own this about 400-hectare site with about 7 hotels now, 1 golf course, about 2,000 houses, and many more. And we are still planning about 3 to 4 hotels and many more projects. So this is how we start off to deal with the environment. And for us, as a commercial company, we are not only just doing the bottom line from the commercial, from the economic, but also to the social and the environment. After all, as a resort specialized company, we realize that the environment, the site, is one of our main assets. And for that, we have a framework, what we call the For Good framework. We start off of Build for Good. This is where the project starts with the design and the construction and run through all the way to the Stay for Good. This is when the guests start occupying, staying in the resort. And now we are bringing this all the way to the supplier chain. So this is all our framework for the sustainability. So the main key is not only during the construction, but also during the operation. So we start with from the concept, design, construction, pre-opening, then operational. All we need to be sustainable. So we have the third-party certification, not only during the construction and design, but also during the operation. Our Build for Good framework, we have 3 key points. One is the protect the environment and remediate the site. If you can see that now, the first site I show you in Bang Tao Bay that is totally devastated, and we remediate into much better site. And we create sense of place or place making by adopting the local architecture, the local building material, the local technology, and so on. And as I mentioned again, that we certified this process not only during the design, but the more important is during the operation. This is just a few examples. We're operating in more than 30 countries, and now I have more projects coming up from all the way South America, Europe, Africa, Asia, China, Pacific, and so on. So our type of project is very diverse, from small, tiny island into rainforest, into mangrove wetland, into desert, snow mountain, even into the city. So all these have the similarity, which is the site is the most important for us, and the environment, because that is our asset beyond the architecture itself. If you can see that on the first side, this is the hotel. The land in the middle, that is whatever left, and the lagoon is extinct mining. This has become now 400 keys room hotel, and the lagoon from the wasteland has become our main asset. And in terms of adopting the local architecture to create sense of place, we are not copying whatever the local language, but we translate it, and we use a lot of local material also. In terms of third-party certification, doesn't really matter whatever. We use from LEED to Green Mark, Green Globe, and what we use the most is EarthCheck. EarthCheck is suitable for us because this is, they have program for hospitality, and they do the benchmarking for same project, same location. So you are not benchmarking a hotel with an office or with a different type of hotel. And the most important is that this is not stopped during the planning and the construction, but going all the way during the operation. When our hotel opened, we just registered as a member of EarthCheck. You do not have any grading. After you pass 1 or 2 years within the standard of the benchmarking, you get a bronze. After you remain in the bronze for a few years, you get the silver. 5 years, you maintain the silver, you only get the gold. So it's not you tick, 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 aim for platinum. Even you get the certification before your project finish. So this is very important for us, because for us, what is the bottom line of this one is efficiency. Every year we monitor the energy consumption, water consumption, on the waste management and so on for the every occupied room night. Let me share with you a few our case study. This is one of our first generation project in Maldives. Our approach is always that the guest experience is the most important, and the guest privacy and the view from the guest room, that is the most important. So this project, we build a prefab, we keep all the vegetation on the island, even though it's small, and we plan as non-aircon building. This is because this island needs to be self-sufficient. This is in Maldives. The same approach we did in Langko in Vietnam. We keep the villa behind the sand dune on the beach, and then we keep the whatever the vegetation along the beach. This is typhoon area. Every year typhoon hit. So if you remove the vegetation, you will creating a problem. You know, it's all the wave and everything. So we raise the villa in order for the guests to have a view from the deck, but we're still keeping all the vegetation. This is Seychelles, 100 hectare site. On the back of the site is very steep mountain with a big boulder, and on the beach, very thin strip behind it's already wetland. So it's difficult place, and the key point is that we are not supposed to change the skyline of the site. So what we do is we put the villa one by one, is in the in between the tree, in between the boulder. You can do the site plan, but at the end, we need to camp on the site for 2 weeks to place the building one by one, because we even cannot even survey the topography. The goal is that to provide a guest room with a beautiful full view and privacy. So you can see one villa is here, the other villa is on the back. This is another project in Ras Al Khaimah. It's about half an hour from Dubai in the desert. If you look at this, the site plan doesn't make sense. But this is the most difficult, because there is no contour plan. The topography changes every day because of the sand dune, the movement. So what we do is we observe where is the stable area, and the green area, that is the nature reserve or the forest reserve of the Gulf tree on the desert. The architecture, we adopt the local architecture. It's not the Persian with the wind tower, not the arches with more like a Mongol architecture. So this is the local language. And the villa, we put it in the very light structure. We use a tent to get inspiration from Bedouin tent. And you can see all the sand dunes come really close. Even the road, that is not determined by us, it's determined by the wind. We align the road where the most stable, because if not, your road will be covered every morning because of the sand movement. Just a few. This is another different example. This is in Mexico. The site is beautiful site facing the Caribbean, but this is very matured mangrove, a wetland. So what we do is that we pull back the resort a few hundred meters from the beach, and we make use the wetland as a circulation. So the gas can go from the lobby to the guest room by the water. This is the lobby area. And we make the upper floor open. This is another hurricane area. So when the hurricane pass, we just let the lobby wet and they pass through. This is the villa where you can see that the natural water is there. When we build this one, we have a crocodile in the wetland, and we have about 50 species. We are debating among ourselves whether we should remove the crocodile, because we also have dugong. But at the end, we keep, and now from 50, we have about close to 300 species, and the crocodile live happily near the beach and become one of the attractions. This is in Maldives. If you look at the water villa, usually the architect or the developer, they try to do is to put the water villa linked to the island, then easy access. But they never realized that the sand along the island, that's moved year round. So you can see that now the sand is more on one side and less on the other side. In the other half of the year, it's different because the sand is moved by the current. So if you put some structure out of the island, that will disturb the sand movement, then will create a different problem. So what we did is that we pull out the water villa. It's almost 2 kilometers away, passing the deep lagoon, and this has become a floating resort above the ocean. The genset, the STP, the reverse osmosis, all is here. Another, in Maldives, different approach. This is very small island. We lease it temporary, and this is declared as a picnic island. We're not supposed to build permanent building. So what we do is that we use very light structure and tent and all put behind the vegetation. And you need to be so light because it's a lot of ecosystem live in the undergrowth. What we do is that we create a very tiny PVC piling, PVC pipe as a pile, and the tent is just sitting on top. This is in China, in Huangshan, where the setting is next to UNESCO village. So it's the architecture we adopt. This is on the tea plantation. Adopt is the local architecture language. So you can see the far, that is the village. So the architecture and everything is very much blended in. This is our flagship in Banyanti Phuket. You can see the area within the moonscape. The lagoon is already there, and we do not have a beach. So what we did is that we make use the lagoon as a part of the transportation, and we create a pool in every villa. So this is where we, the first resort with a private pool villa in every villa, because we don't have a beach. In early year 2000, I found this site. This is in Shangri-La in Yunnan, in southern part of Tibet. Very beautiful valley, village, very pristine. This is the village of the Kham Tibetan. One village is only probably 6 households, very small. So it's nice, very peaceful. Our site is on the other end. We're debating what kind of architecture we're going to put here. So I decided that non-architecture, because whatever you put here, it will be dominating the whole village and the whole resort. Because it's one village is like a hamlet, it's nice, small, tiny, beautiful house. So what we do is that we have a site for about 32 keys. We do, and we want to emulate how is this Tibetan house. You can see that the Tibetan house is, this is the 4 bays, one of the big house, and wooden structure, but enclosed by ram earth architecture. This is one of the big house. They have a courtyard with a big dog, and the column is almost 1 meter diameter, the wooden column. They have the hierarchy of the column. For the poorer, they have 3 bay house. They don't have the courtyard house, the courtyard yet. So if this 3 bay, they want to upgrade into 4 bay, they need to redo all over again because there's no space to grow. Or if the 4 bay, they want to grow to the bigger 4 bays, they have put the extension in the courtyard, they have no place to go, they need to build a new house, totally a new house. So what they left is the ram earth. So we see this potential, then I start looking how to buy the second-hand house. So we bought the house, and Tibetan house is the plan is very simple, and inside is beautiful. It's very colorful, and the fireplace is the heart of the house, where everything is take place here. So this is when the resort is finished. And it's quite unique and become the new definition of the luxury resort because we define the luxury. And it's good for the CSR, good for the economic and the cultural preservation. When you approach to this village, you never see where's the hotel. Our guests keep asking, where is the hotel, where is the hotel? Because they expect something else. And so we buy the house, we dismantle it, and we reassemble it all by local. This site is 3,400 meters above sea level, so pressure is high. We hire a contractor to lay the infrastructure. Within 2 weeks, all go home. They cannot take the pressure. So at the end, we employ the local villagers to do the work. So this is dismantling the house. The house is a pitch roof, but actually the pitch is just a cover. The flat roof is from up the actual roof. We mark, before we dismantle, we mark the column and the beam and everything, so for the process of reassembling. And they remove by hand one by one. This house built without nail. Literally, you can just remove. And as I mentioned, that they have so many columns, and the column have hierarchy, different type of wood, different time to cut the wood. So we transport it to our site, all sorted out, and based on the number, manually reassemble again. The external wall initially is a compacted earth, but if we do that, we will cut the whole hill in order to build her house. So we consciously replace the compacted earth with the concrete hollow block, and we add more window. So this is the interior work. We put back all the panel, we're cleaning up. You can see the exterior wall, we have more window. The plaster outside is from the local mud, so we don't use paint, so the color is blended in with the village. This is the lobby building. The landscape also, we use the local stone and the local language. This is the hotel. So it's like another hamlet, another village. And we employ the local as a tour guide. We do a lot of trekking, and we adopt the color of the local fabric for the interior. This is the lobby building. And this is the interior of the Tibetan house. We adopt this color scheme. This is the lobby. And we use the fireplace as the heart because it's also quite cold place, the restaurant. One of the challenge that this is cold place during the winter, and the old house, they do not have the modern heating, the modern this one. So when we put in the guest comfort, that is another challenge because there's a big house. So what we do is we split the house into two. One is a bigger room, one smaller room. The lower part, which initially was for cow, for the yak to live, we lift it up higher into, make it into a bathroom. So this one villa, this is a smaller room, the bathroom, the bigger room. So you can see that even the interior, we try to simulate how the Tibetan live. They don't have furniture. The bathroom. The way Tibetan, when the guy courting the girl, they are not praising how beautiful you are, but they're praising the house. How big is the column, how good is the staircase, how good is the door, and everything. So they're praising from the house to the dog to the rafter, but not the girl. This is how the way they do, how important the girl. Thank you.
Thank you, sir, for that wonderful presentation. I now call upon Javier Covalan, is an architect by the Faculty of Science and Technologies of the Catholic University Nuestra Señora de la UC, I think for short, yeah. Has done postgraduate studies in Rome and at the universities of La Sapienza, and his PhD, so I'll not name the institute. And his professional practice as independent is from 1991. He wins several public and private competitions like the rehabilitation of the Municipal Theatre of Usuchon and Cultural Center of Spain, with several projects in international publications, Casabella, Domus, Summa, Plot, being the most important O'Neill Ford Duograph series, Volume 5, and an archive, Revistes Zera di Architectura, and something more that I can't pronounce. So I please welcome you on stage. Thank you.